Hi, so if you can turn to page 19 of the Unit 2 packet, today's classwork focused on the leading coefficient, odd and even degree functions, and end behavior. Now I know we already did numbers 25 and 26 within the classwork example, so those should be done for you. So what I'd like you to do is I'd like you to hit pause and try out 27 and 28 on your own, and then you can hit play and see how you did. Okay, so if you recall, the first thing I'd like you to do is I'd like you to go to either end of the graph and write whether it's pointing up or down. So both of these are pointing down. Now, part A wants us to decide whether it's an odd or an even degree function. So if both of these are pointing in the same direction, it means it's an even degree function. Now, part B, we were just trying to decide whether there's a positive or a negative leading coefficient. So if we look right here on the right side, right, we only look at the right. Since it's pointing down, it means there's a negative leading coefficient. Okay, now part C, we start off our end behavior the same way every time. Okay, I wrote it down here just to give myself a little more room, but this is how we started off each time. Remember, this means as we go to the left, well, our graph is pointing down. So I could write negative infinity. And this means as we look to the right, the y values are also pointing down. So this is also going to be negative infinity. Okay, number 28. This is also going to be an even degree function because both ends are pointing in the same direction. They're both pointing up. Now, to figure out the leading coefficient, we only look at the right side. So since the right side is pointing up, that means we have a positive leading coefficient. Okay, so part C, the end behavior. All right, so we start off writing the same thing every time. And make sure you didn't forget anything. Make sure you don't forget your arrows, right? You don't want to put equal sign because this means approaches. Make sure you didn't forget to write f of x. But this means as we look to the left, it's pointing up. So up means we're approaching positive infinity. The y values are getting very big. This means as we look to the right, well, on the right, our graph is also pointing up. So the y values are also approaching positive infinity. Okay, on the next, I want to say 2 pages. I'd like you to try out numbers 29 through 31. They're all multiple choice. And then you can hit play and see how you did. Okay, so hit pause and try those on your own. Okay, so if we look at number 29, these are both going to positive infinity. So we're looking at which graph shows up, right? Up on the left and up on the right. All right, well, I see that happening in choice 4. All right, now, with number 30, don't be tricked. Look what they did here. First of all, 3 real zeros mean it's intersecting the x-axis in 3 spots. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that didn't even help us out, right? They all have 3 real zeros. But look what they did here. They put the right side first as x approaches positive infinity. So we're looking for on the right, it's going down, and on the left, it's going up. Okay, so if we look, the right has to be pointing down, because look at choice 1, the right is pointing down, and the left has to be pointing up. Look at that, the left is pointing up. Choice 1 right here, this is our answer. So choice 1 is our answer. Okay, now, number 31, we're looking for the left pointing up and the right pointing down. So look at the 2 pictures they give us graphs of. This does not show the left up and the right down. So choice 2 is out. Okay, choice 4. Actually, they're both going down. We want left up, right down. So choice 4 is out. So now as far as choice 1 and 3 go, you could do one of 2 things. You can graph these in your calculator, right? Or if you want to think about it logically, right? This is a 4th degree function. So it means it's an even degree function. Both ends are pointing in the same direction. And since there's a positive leading coefficient, doesn't that mean that the left is going to be pointing up and the right is going to be pointing up? Right, that graph is actually, it's a 4th degree function, so it's a quartic. It's actually going to look something like this. But even if you thought about it logically, we should realize this is going up and up. So this is not our answer. But, you could just go to y equals in your calculator and plug that in and look at the graph if you want. Okay, now this, we have a negative leading coefficient, which means the right side is pointing down. And if it's a cubic, right, an odd degree function, it means they're opening in different directions. So if it's pointing down on the right, doesn't that mean on the left it has to be pointing up, right? So something like that. You could graph it in your calculator and look, but this is what we're looking for. Look, left up, right down. But again, just go to y equals in your calculator and graph this and you'll get a much better graph. Choice 3 is our answer. Okay, now, if you can skip ahead, we're going to actually skip over 32 and 33. Those are a little tricky, and we're going to talk about those when I get back. But if you could take a look at the next page, I'd like you to try those two examples on your own. Okay, so if you didn't hit pause, I'd like you to hit pause, right? Read what all this says and see if you could pick out the graph, and same thing here. Read what all this says and see if you could pick out the graph. Okay, now technically what you could do is, see how it says A, B, and C are all positive real numbers? You could just pick a number for A, pick a number for B, and pick a number for C and plug it in here, here, and here. So for example, if you wanted to, I just picked 1 for A, 2 for B, and 3 for C. I picked positive numbers. I picked positive 1, positive 2, positive 3. And you could just graph this in your calculator and see which one of the graphs matches this equation. Okay, now I'm not going to do it this way. So I'm going to think about it logically. Okay, so let's think about this. See this A? Now when it says A, B, and C are all positive real numbers, what that means is that you're going to keep the signs of what's there. Because for example, let's just say that B was a negative number. If I plugged in a negative number here for B, like -2, wouldn't x minus -2 make that say x plus 2? So then all of a sudden we'd have a plus sign in the parentheses. The reason they say that A, B, and C are all positive real numbers is they want you to keep the signs of what you see. So just keep the signs. So basically, A is a positive number, right? If we have a positive leading coefficient, doesn't that mean the right side of our graph has to be pointing up? Kind of like we see in choice 3 and in choice 4. Okay, choice 1 and choice 2 are out because look, the right side's pointing down. They have negative leading coefficients. Okay, now let's go to this first factor. It says x minus b. If we have a factor at x minus b, doesn't that mean that we'd have a 0 at x equals positive b? And look at this in choice 4. We have a factor at, a 0 at positive b. Now, see how we have a factor here at x plus c? If we have a factor at x plus c, doesn't that mean that we're going to have a 0 at x equals negative c, like we see right here? And also, one more thing I want to point out. See this square right here? That square means that we are going to have multiplicity. And multiplicity, you're looking for where the graph bounces off the x-axis. And look right here. Isn't this bouncing off the x-axis, right? So choice 4, wow, I really covered that up there. Choice 4, you see it under here, choice 4? That is our answer for number 34. Okay, now 35. I'm going to I'm not going to plug in numbers, although we could. It's similar to 34, but okay. When they say A, B, and C are positive numbers, what that means is keep the signs of what you see. Do not change their signs. That's all that means. Okay, leave what you see there. So we have a negative in front of a positive A. So basically, we have a negative in front of a positive number. So it's going to make that entire leading coefficient negative. So if we have a negative leading coefficient, we know the right side of the graph has to be pointing down, like in choice 1 and 2. So choice 3 and 4 are out. Now, this looks a little crazy to me. We could figure that out if we need to, but let's look at this. It says x plus b. If we have a factor at x plus b, doesn't that mean we're going to have a 0 at x equals negative b? So look at these two answer choices. Which one has the negative b? Choice 1 does right here. So choice 1 is our answer. Okay, and that's it. That's the homework problems for today. I hope you did well with them.